Alrighty, here we go. Let's get into reviewing for this Unit 11 exam. Anyway, let's see what we can do here. Yes, I want to continue recording, you dumb computer. Okay, so anyway, here's the things you're supposed to be responsible for right now. You are supposed to know the equation Q equals mc delta T. And as of right now, you are supposed to be able to work any basic problem that might give you one of these things. You are supposed to know that C stands for specific heat. You are supposed to, wow, I messed that up. You are supposed to know every material has its own, thus specific heat. Anyway, you're supposed to be familiar with some of the different units. You're supposed to know, for example, that 1 calorie is equal to 4.186 joules. These are things you know. You're supposed to know that if you're talking about water, that C for water is 4,186 J's per kg Celsius degree, or 1 calorie per gram Celsius degree. Those are things you are supposed to have memorized. That's pretty much the only C you're supposed to have memorized. Well, I take that back. Not for this test, but the next one. You're going to have to make sure and know that when you're talking about water, if it's a solid, then water is a 0.5. If it's a liquid, then water is our famous 1. And if it is in a gaseous state, water is 0.48. Now that you will have to know, not on the test, not on the very next test we take, but just my camera. But anyway, on the next test we take, you're going to have to know those 3 bits of information. All right. The only other equation you're responsible for knowing for this test is ML. Q equals ML to be exact, where L can either be an LF or an LV. Now, anyway, most of the time the only 2 I told you to remember was like this: 80 cal per gram, and LV, these are for water, is 540 calories per gram. So that's the 2 I told you to remember. Just remember, those are both for H2O. Any other L's you should be given in the problems that you are asked to work. Now, I know we have this ability to use calories in this problem, but I'm going to throw something out. When you take this test, some of the first and easiest problems on the test are going to be just basic Q equals mc delta T and ML questions. Just make sure, though, you're going to have some equations where you're either going to go mgy equals, and you could make mgy equal to mc delta T. So you could set potential energy equal to that. Don't forget, you could also take mgy and set equal to ML if you wanted to. So this goes for everything. So we could set 1/2 mv square if you had a bullet or something that was shot and got hot. We could set the bullet equal to, again, either one of these 2 things that's up here. So any equation we've ever had for energy, we could set equal to either ML or mc delta T. Also, don't be shocked on the test if you have a power question. Well, just remember, power is energy over time. Well, so how does that apply to us? Well, remember, mc delta T, that is energy, heat energy. So that means on the test, you may either end up going mc delta T over time, or I might give you a question that says power equals ML over time. So either one of these 2 are possible in test. Now, I just want to say one gigantically important thing. If you do any of this stuff, where you set things equal to mc delta T like this, or set power, everything has to be joules and kilograms. These equations will not work if you're not in joules and kilograms, which means, for instance, if you're talking about water, you would need 4,186 in the problem. So anyway, that's got us our basics on this. This test is also going to have like the classic question where you've got water and you heat up a piece of metal and drop it into the water. So really, if you're wondering, the only thing you're missing from this first test is going to be like ice dropped in the water that has to melt and all that kind of stuff. So let's go in and work those example problems that I kind of gave you to take a look at. And of course, if you're a random person who found this video, not one of my students, then this won't be as much. But anyway, here's the test. Pause and you can take a look at. There's 1 through 4. So all right, good. Well, I'm going to go ahead and work these problems for my students that are watching this. So let's take a look and see how we did on each one of these. All right. First question says a 10 kilogram piece of aluminum. So it's given me a mass of 10 kilograms. It's given me a C of 900, and it's in joules and in kilograms, Celsius degrees. Is warm, so its temperature. And notice this, it just says its temperature increases by 5.0. Now, it does something unique. It says this 5 Celsius degrees. And we've talked about this before. When you see something give you Celsius degrees, this is not a temperature final. It's not a temperature initial. That is your delta T. There's your C. Here's your mass. And all it asks you to do is find the heat. So Q equals MC delta T, and you should have had 10 times 900 times 5, which let's see if we can't figure this one out. This will be 4500. Add another 0 on there, and we're in joules, so it should have been answer A to this very first question. Well, that was good. Let's see if all the rest of them are that easy on here. The next one says a 3-gram bullet is traveling at a speed of 240 meters per second. Wait a second. A bullet traveling with a speed, that's a 1/2. That bullet's got kinetic energy. And it says this bullet gets shot in a wood post. Now this is big. Half of the energy. Let's see, half of the resultant heat energy remains in the bullet. So basically it's saying this. It's saying that 1/2 this energy actually goes into heating up the bullet is what it's saying. So half the energy actually goes into heating up the bullet in this question. So I'm just going to write it like this. 1/4 mv squared equals MC delta T, because it says it heats up the bullet. Now, the masses of the bullet are not important. They're going to cancel out. And let's see what it tells me. Now, this one tried to do some weird junk right here with telling me C. So I'm going to see if I can't decode it here. All I really need to do to try and interpret this crazy looking C, it's in kilocalories and kilograms. All I'm going to do is take that number 0.0305 and times it by 4186. So my C is actually 120, I'm going to say 128 joules per kilogram. So there's my C in this problem, 128. So this is going to be 1/4 times the velocity of the bullet, which, let's see, where's the velocity of the bullet was 240 square, which that's what people forget, equals 128, and the problem wanted me to find the temperature change of the bullet. So let's see if we can't plug this in and get an answer for it then. So this would be 1/4 times 240 square equals divided by 128. So I got 112.5 Celsius degrees, and that's great because that's answer A on the homework. So awesome. So let's go and do number 3 now. So far, I am making 100 on this test. I would hope so. I actually make a living talking about this. Let's take a look at the next one. All right, the big thing I see on the next one, I see a wattage here. That means this is a power question. The second I see that watts, I know this is going to be power equals something over time. Now, the only question I have, is it going to be an MC delta T, or is it going to be an ML over time? Well, it says what is the temperature increase. So this is an MC delta T problem. So there's my equation for this one. So power is equal to MC delta T over time. And it gave me a power of 800 watts. Oh, this is going to be easy. So 800 equals, looks like it gave me a time. It said 10 minutes, so that would be 600 seconds. It gave a mass of 4, and this is water. Now, this is where people mess up. I told you a little while ago, if you're going to do this, C has to be in joules and kilograms. So this needs to be 4186, and I'm looking for that delta T out there. So let's do this one. 800 times 600 divided by the product of 4 times 4186 in parentheses equals 28.7. And I just did my math. Nope, I did my math good. 28.7 degrees Celsius. Actually, that would be Celsius degrees. It's kind of like Bond, James Bond. Let's see, and the answer on here would be C, 29. Although it says degrees Celsius, which in theory is not the right unit. But anyway, goofy textbook people. All right, next question is a calorimeter question. Piece of copper is being dropped in the water. So let's draw this problem out. We've done a bunch of these by now. Matter of fact, I think you probably just had a quiz on it. So anyway, the question says we've got a calorimeter. It's got water inside of it. It says there's a piece of aluminum that is going to, is it aluminum? Nope, it's a piece of copper, Cu, cuprum. It's going to be dropped into it. Let's see if we can fill in everything here. It says that the copper is 80 grams. So copper is 80 grams. It says that the water I've got is 250 grams. The calorimeter is 300 grams of aluminum. And we need to know that aluminum, so we know all our C's. What is the final temperature of the system? So we are looking for TF in this problem. Now, it goes on to tell us that the initial temperature of everything here is 10 degrees. Well, if the water is 10 degrees, then the calorimeter is also at 10 degrees. It says that that metal is a blistering 295 degrees Celsius. So there's what it tells us about the metal. All right, now all it's going to do is going to drop that in there. Well, I think we've got everything we need. Yeah, I feel good about this. So how many Q's should we have? 1, 2. We should have 3 Q's in this problem as we work it out. So we should have a Q for the copper. And that copper is going to go, it's going to cool off. So that copper is going to cool off from 295 down to some temperature final. Plus, we should have a Q for this water. And that water is going to go from 10 to some temperature final. It's going to heat up. Copper is going to cool down. It's going to heat up. And then we're also going to have a Q for the aluminum that it's made out of to go from 10 to some temperature final. We'll hit equals on this, and we'll see if we can't write this out now. So we've got 3 MC delta T problems here. Well, let's just plug in our numbers. Q for copper, and copper is one I don't really know. 092. There we go. So this is going to end up being, see if we can get this. Mass of copper is going to be 80 times 0.092 times TF minus 295 plus, let's see what this next one. Water is going to be 250 times 1 times TF minus 10 plus the aluminum, which is going to be 300 times 0.215 times, and it would be TF minus 10 on the aluminum. Temperature final minus temperature initial. Everything would be set equal to 0 in this problem. So all you got to do now is distribute this and get your answer, which I suggest writing it out as you go. 80 times 0.092 is 7.36. So this is going to be, at this point, 7.36 times TF minus 7.36 times 295, 2171, so minus 2172, plus, hey, I like this one, 250 TF minus 2500, and then let's break this last one now. It's getting kind of sloppy here. 300 times 0.215 is 64.5, so this is going to be plus 64.5 TF. Let's see, that would be times negative 10, so minus 645, set everything equal to 0. Good grief. So this is where you should be. So combine your like terms. 7.36 plus 250 plus 64.5. So our terms combine to be 322. 322 TF should end up being minus something over here. So 2172, 2500, and 645. So minus 5317 equals 0. So TF then is ultimately equal to, divided by 322, and I've got a total of 16.5 degrees Celsius, which just so happen is on the test. That is my answer to B. Cool. All right, so far I'm doing pretty good. All right, only 2 more problems left to go, and this test review is done. All right, so let's see what we got in the next one. I swear I just smelled a cat pee. I don't know how. Anyway, sitting here at my desk. Well, I guess anything's possible. All right, number 5. We've got 10 grams of milk, not ice, just milk, and it's added to some coffee. And let's see. Oh, this is nice. It says neglect the heat capacity of the container. So all someone's doing is taking milk and pouring it in the coffee. So we got 2 Q's. We've got a Q for the milk plus a Q for the coffee. No, wait, I started to say la leche. That's that. Coffee is, crap. I don't know. Anyway, so I've got the 2 Q's, and that's it. So compared to other problems we've done, this one's a nice one. It's just y'all don't get used to, instead of a hot piece of metal, we've got some nice, cool, refreshing milk being poured in our coffee. Well, it says here that the milk is 10 degrees. So the milk is 10 grams at 10 degrees. And it looks like we're trying to see what the temperature is going to be. So it's going to cool it off. The coffee, of course, was hot. It was 90, and we're going to try and cool it off. So compared to the last one, this one's really, really, really nice. It said we had 10 grams of coffee and 10 grams of milk and 160 grams of coffee. Good. I hate when people put like a ton of cream and stuff in their coffee. It's like they're drinking coffee-flavored cream is all they're doing. But anyway, that's just a personal thing. All right, so that's an MC delta T, and that's an MC delta T. So I'm going to write 10. Now, I know this is milk, but milk is basically made out of water. So I'm going to say times 1 times TF minus 10 plus 160 grams of coffee, which is basically made out of water, times TF minus 90. Set it all equal to 0. This was probably the cleanest problem you've done so far. This would be 10 times 1 times TF. So that would be 10 TF. 10 times negative 10. So that would be 10. So that would be 100. Plus 160 times 1 times TF is 160 TF. And then minus 160 times 90, 14,400 equals 0. Combine like terms, so it'd be 170 TF minus 14500 equals 0. Therefore, TF in the last step is equal to, you should already have beat me to this, 14,500 divided by 170 is 85.3 degrees. And it just so happens 85.3 degrees is answer A. I am full-blown making 100 on this test. This is terrific. All right, so let's go and take a look at and do number 6. I'm going to get another sheet of paper just in case number 6 takes any more room. So far, these problems, they're not too bad when they're just MC delta T questions. Let's see if we get another one of those MC delta T type questions here. How much energy is required to vaporize an ice cube at 0? And it just wants us to vaporize. Oh, I love this one. Nothing but an ice cube that's already at 0 degrees, and all it's saying, it wants you to vaporize it. So turn it into steam. It doesn't say steam at 120, so I'm just going to assume plain old 100-degree steam. Well, I love this problem. It's the easiest of all the ones that we do. We start at 0, so our first Q is just a QLF. So we can start melting it right from the get-go. Once we melt the ice, turn it into water, we then have to increase its temperature from 0 to 100 if we want to boil it. And then we need one more Q. We need a QLV to boil it away. So by starting at 0 and ending at 100, it reduced it to just 3 Qs. And so we're actually not setting it equal to 0. We want to know what this is. And it says you got 1 gram of ice. Well, this would be 1 times 80 plus 1 times 1 times 100 minus 0, TF minus TI. Well, that's 100 plus 1 times 540. Oh, equals, oh, wait, not equals 0. We ain't doing that kind of question. You got to watch out. Some of y'all will do that too. If the problem asks you to solve for energy, you're actually getting this equals whatever. So this would be 80 plus 1 times 100 is 100 plus 540. So we've got 640. So where are we at? 720? And just watch out on the test. If the answer wants your answer in joules, make sure and convert it over to joules. But anyway, well, we've got that one done. Hey, I'll tell you what, let's do one more. I know I didn't even ask you to do number 7, but let's just see. How could you have done on this test? So far, I ain't seen nothing that you should have problems with. So let's do one more. Number 7, excuse me. 7 here, I'll hold it down if you haven't read it yet. But we've got a lead bullet traveling at a speed, hits a block of ice, and melts the ice. So this one's really easy. It's just saying 1/2 mv squared is equal to, by the way, we never did get an answer for that last one, but it was B, so there was the answer. But anyway, a bullet is going to melt some ice. There, that's all there was to it. We just set those equal. And now, here's the thing. These masses are not canceling out. I almost did it just now. But you see, this mass on the left side had to do with the bullet. The one on the right side is asking how much ice you melt. So what's happening in this problem, somebody's got a cube of ice, and they have shot a perfectly good bullet into the cube of ice, which of course melts some ice. And your question is to figure out how much of this ice is going to get melted. Well, all I want to know is how big is the bullet. It says that the bullet, 1/2 times, it says that the bullet is 0.003 kilograms, and that the bullet is traveling 240 meters per second, equals mass of ice. Now here's the thing, that ice I'm melting it, so that's an LF, so I've got to have LF in terms of, oh my goodness, it's 80 calories per kilogram. Well, all I got to do to get it in joules is go 80 times 4 times 4 1,186. Holy cow, 334,880. My goodness. So LF, this is why I don't have it memorized. LF for ice is 334,880. Good night, that's a healthy number. So let's plug in our numbers. A half times 0.003 times 240 square. Divide by 334,880 is equal to, how did I get a negative in here? I don't even know. I had negative at the beginning. Let's ignore that negative. So I've got 2.58 times 10 to the negative 4 kilograms. Good grief, that's not very much. But luckily, answer D is 2.6. So we have got the answer to this one. So basically, for the test, it is nothing but MC delta T questions, ML questions. It might take this, mix it in with an MGY, a 1/2 MV square, a power equals energy over time. Then the rest of the test is nothing but MC delta T plus MC delta T plus questions. You can hardly read that last part. I wish people would be quiet. But anyway, thank you. All right, well, you should be good to go for this test, so good luck and work a couple more review problems. See y'all later. Bye.